Thanks. Let me slide over so nobody's blocked. Thank you, Mikola, for the introduction and the invitation, and also to Alessia for the co-invitation. So this is different from, I mean, this work you'll see both has continuity with the work I've been doing for some time now, but also different. In a way, Professor Comenta has just published a book called The Ecomedia Turn. And in a way, you might think of this new project that I've been working on relating to trees and forests as not ecomedia, but ecomediation. And so I'm trying to take seriously what I argued in the non-human turn, that mediation is not simply about screens, film, visual culture, and so forth, but that mediation is actually a sort of fundamental process of reality of non-human entities. And so this is an attempt to think about what trees have to offer us. And it's part of what may be a larger project. I have another couple of pieces I've also written, but this is about half of this is brand new material. So I will be interested to see if it works and if you find something interesting. Okay, the
Come si chiama con
like
this one?
better. First section is called Wood Wide Web. Trees are in the air these days. Deforestation is widely recognized as a major contributor to climate change. Contemporary writers publish large, sweeping novels about humanity from an arboreal perspective, and artists create projects that dramatize the ecological implications of deforestation or collaborate with trees as artistic agents and medium. But scientific, literary, and artistic interest in trees is not a new phenomenon. Many indigenous peoples have complex legends, traditions, and practices involving trees as non-human people. From the classical era on, myths and stories about people turning into trees or vice versa have inspired numerous works of literary and visual arts. Trees have long been an important object of study for natural history, and the prominence of logging as a crucial extractive industry for capitalism and settler colonialism has generated the development of forestry and forest conservation as a way to maximize timber production on the one hand, and to protect, if not preserve, forests from overwhelming future devastation on the other. Beginning in the late 1990s, during the early explosion of internet enthusiasm in the West, the concept of a wood wide web began to be adopted by botanists, dendrologists, and natural scientists, based in part upon research by Suzanne Simard and others showing that trees reciprocally exchanged nutrients with mycorrhizal fungi through their roots. And so here's just a couple of illustrations to show how underground trees through fungi are sharing nutrients with each other and with the fungi underground. The editors of the journal Nature coined the phrase Wood Wide Web for the front cover of its 7 August 1997 issue, which featured a story about Simard's early research. Simard's contention that trees communicated with one another in something like a wood wide web was not initially well received by academic botanists, dendrologists, and natural scientists. Precisely what makes these claims so exciting today for scientists, artists, and an ecologically inclined public, the idea that cooperation was as important as competition in the relations among different species, as well as the claim that trees, fungi, and plants communicated with one another like humans do. This which is so exciting for us today, was what caused many natural scientists to discount Simard's claims as unproven at best and as nonsensical at worst. Over the past 2 decades, however, Simard's claims have begun to be more widely accepted among her peers. Despite some continued resistance from academic scientists, the phrase Wood Wide Web has stuck around. Beginning in 2012, its usage began to grow significantly, continuing to increase dramatically for the next 10 years. In today's lecture, I'll explore the concept of tree mediation or arboreal entanglement to think about how contemporary science, politics, and culture are imagining the role of trees and forests in shaping the future of humans and non-humans in the Anthropocene, particularly in relation to deforestation, climate change, and biodiversity. These concepts work to decenter the human and allow us to learn from trees and forests how to undermine human exceptionalism, which expresses itself most often in the form of conceptual or rhetorical dualisms that separate the human from the non-human or more than human. These dualisms understand the non-human or more than human as animals, plants, organisms, climatic systems, primitive societies, or ecosystems. So what I want to do, as I've tried in much of my recent work, is to break down this separation between the human and the non-human or more than human. I begin by taking up the question of what trees and plants have in common, after which I lay out some of the operations of arboreal entanglement to explore the specificity of trees among the plant world at large. I conclude the talk by unpacking what is at stake in the Wood Wide Web metaphor, interrogating this increasingly popular analogy in order to consider the effectiveness of such metaphors in raising eco-political awareness. Section 2, plants are the real mediators. Like trees and the mycorrhizal networks that connect them, plants also have come to be understood as sharing affinities with the Internet's distributed modular infrastructure. One of the key features distinguishing plants from animals is their distributed structure. Animals have evolved by differentiating the basic functions of life, like cognition, perception, nutrition, digestion, waste, or reproduction, and distributing these functions to different organs. These organs cannot be divided from the rest of the animal. Without a brain, heart, or lungs, for example, an animal cannot continue to live. In plants, however, these vital functions are distributed throughout the leaves, stems, and roots. If part of a plant is removed, new growth will replace it. And we all know this, anybody who has house plants, if you can divide them, you cut something off and prune them, new growth comes out. If you cut my arm off, I don't get another. I mean, except through technological extension. Our body, Stefano Mancuso and Alexandra Viola write, really is indivisible. If we're cut in half, the two halves can't live separately. They die. But if we cut a plant in half, the two parts can still live independently for the simple reason that a plant isn't an individual. Animals like us are in that sense literally individuals. We cannot be divided and survive. We're not. Plants, on the other hand, can be seen as something like Lezione individuals, multiply divisible beings that generate new growth, new individuals, when they are split into two or more parts. In discussing how plants communicate, Mancuso and Viola contend that despite the similarities, a plant's internal communication pathways have a completely different architecture from those of an animal. Whereas animals are equipped with a central brain toward which all the signals are directed, plants, by virtue of their modular and iterative construction, utilize multiple data processing centers, which permit them a very different sort of signal handling. Contrasting the function of the roots of a plant to the brain of higher forms of animals, they contend that each root tip is a true data processing center. It doesn't work alone, but in a network with millions of others that make up the plant's root system. Now, this distinction between central processing in animals and distributed processing of plants is not universal. Octopus, for example, have processing distributed around their body, and there are other forms of animals that do, but primarily, especially for land animals, this holds true. In addition to their entanglement in underground mycorrhizal networks, plants and trees produce the oxygen that animals breathe, without which there would be no animal or human life on Earth as we know it. Plants, both you see here, enabled our coming into existence on Earth through photosynthesis, creating the oxygen that made animal life possible. And today we still depend on them for our survival. They're at the base of the food chain. They are also the origin of energy sources, fossil fuels, that have sustained our civilization for thousands of years. Emitting as a byproduct of photosynthesis the oxygen that animals need to live, plants make animal life on Earth possible. If all animal species were to disappear, plant life would continue without very much change. But if all plant life were to disappear, animals, with the exception of a few multicellular anaerobic organisms, would soon follow them into extinction. While human and non-human animals are dependent on plant life for their continued existence, this dependence is not mutual, but asymmetric. Emanuele Croce explains this dependence in terms of the immediacy of plant mediation. Unlike plants, he claims, higher life seems never to have had immediate relations with the inanimate world. Croce remediates the idealist claim expressed most powerfully by Hegel that humans can never have an immediate relationship with the world. He denies such immediacy to higher life more generally, even while ascribing immediacy to plants, because so-called higher forms of life are heterotrophic. That is, they are dependent on energy produced by the lives of other living beings for their sustenance. They do not have an immediate relation with the material world, but exist as something like forms of hypermediacy. Plants, on the other hand, are autotrophic. They have no need for the mediation of other beings in order to survive, nor do they desire it, Croce writes. Plants require nothing but the world, nothing but reality in its most basic components, rocks, water, air, light. Plants are the real mediators, he writes. They are the first eyes that appeared and opened themselves onto the world. They are the gaze that came to perceive it in all its forms. The world is above all everything the plants could make of it. They are the ones who made our world, even through the status of, though the status of this making is quite different from that of any other activity of living beings. As forms of radical mediation, whose relation to the world is immediate, plants are ontogenetic. They do not come into the world belatedly after the habitable world and its animal life are already in place, but they create the conditions from which the conceptual opposition between animal life and the world can emerge. Because plants, Kocha says, produce the space in which they live rather than being forced to adapt to it. They have modified the metaphysical structure of the world for good. Plants provide an alternative to a traditional dualistic ontology in which natural and by extension technical forms are understood as separate from their creators. Plants, Kocha writes, coincide with the forms they invent. All forms are for them inflections of being and not merely of doing or acting. Plants offer the grounds of an implicit critique of Aristotelian hylomorphism, in which every physical entity is seen to be composed of two distinct qualities, matter and form, with form immanent to and preceding its realization in matter. Kocha contends instead that the forms plants take are not produced by an agent or action external to them, but coincide with their very being. Plants enact the immediacy of metamorphosis. To generate always means to transform oneself. He continues, unlike consciousness, which does not know how to conceptualize forms. Unlike consciousness, which does not know how to conceptualize forms without first distinguishing them from itself and from the reality of which they are modeled, the plant enacts the absolute intimacy between subject, matter, and imagination. To imagine is to become what one imagines. Form in plants is not distinct from matter, but absolutely intimate with it. So what this, just to explain a little bit what's going on here, what Kocha is saying about plants, and not just Kocha, Mancuso and Viola and other botanists say the same things, is that plants grow by dividing. You have a root and it stem branches and that branches and so forth. And every time it grows, it creates its form. There's no prior form that exists. Plants, the same plant can look very differently depending on how it grows, where it grows, if accidents cause it to lose part of its structure. Whereas with animals, we have a prior form genetically, ontogenetically in our genes. Humans, obviously with strange exceptions, come out with 2 arms and a head and 10 fingers and things like that. There is this form that pre-exists, in a sense, the growth of humans. Similarly, when one is creating a form in art or something like that, one imagines, so this argument goes, the form exists in some sense in imagination and then gets materialized in matter. So that imagination and the formal materialization are separate. This is in Aristotle's conception, but in, I think, many common conceptions of creation. Whereas for a plant, growing itself creates the form. It's intimate. There's no divide between becoming and the form it takes. So Kocha then elaborates on this absolute intimacy that plants have between subject matter and imagination in terms of the hypermediacy of breath, writing that plants and all other life co-create the atmosphere and the biosphere through breath and breathing. And we saw Mancuso and Viola said something very similar. The world is the matter, the form, the space, and the reality of breath. Plants are the breath of all living beings, the world as breath. Because all life begins and ends with breath, photosynthesis for plants and breathing aerobic breathing for animals, life is always engaged in the process of remediation, mixing the breath of the organism, plant, or animal with the planetary breath that is our atmosphere. Breath is the art of mixture, what allows each object to mix with the rest of the objects to immerse itself in them. And I call this a form of remediation because that argument in remediation is that all media are mixtures. There is no pure medium, but every medium remediates each other. In the same way, as we live, every breath remediates. We take in breath from the atmosphere, it goes through our system, and we breathe out. So our body is an agent of remediation. Koch insists that atmosphere is a form of collectivity, co-created by plants and animals, and defined not by homogeneity of substance or form, but by mixture. Our breaths are always mixing with the atmosphere, which circulates through our bodies in order for them to live. In other words, breath is a form of radical mediation, not coming in between living things and the world, but helping to generate the atmospheric medium which makes terrestrial life possible. While we breathe, our living bodies are always producing mixtures or mediations, which then mix with and change or remediate the atmosphere, environment, or medium in an ongoing cycle. When living beings stop mediating and remediating the atmosphere, they die. But atmosphere is not the only ontogenetic medium in which plants live. In an exciting work on eco-affectivity, Marjolein Uhle suggests another way in which plants can provide a model of intimacy between subject matter and imagination. Uhle offers the entangled coexistence of soil of the earth as a model for a new us, a form of collective eco-affectivity among human, non-human, and more than human entities. Not unlike atmosphere or breath, Uhle writes, thinking through the material and ontogenetic function of soil is crucially important to reimagine us participating in a new affective entanglement, where entanglement following Stanger's, Isabel Stanger's, indicates entangled coexistence. That is the emergence of constellations that are not to be grasped as a system of functionality and of parts and whole, but rather as assemblages due to bricolage, that is the construction or creation from a diverse range of available things. Uhle is trying to develop this concept of eco-affectivity, to develop a kind of model for a new ethical relationship between us and the world. And soil is her sort of example, is her model for how that might work. And I'll say a little more about that now. She describes soil as an active and ontogenetic boundary surface as a process in itself, in which a system of layers critical to life on Earth grows out of fine rock particles. Soil is not only made of rock particles, however, but is further entangled with atmosphere and breath. In that, she says, the functioning of soil depends for approximately 50% on soil pores, P-O-R-E-S, like the openings. Like in your skin, we have pores, so forth. The mostly invisible interstitial places that form its connective tissue. Although these pores may appear void, empty, they are not, but they're filled with either air or water or both, depending on the soil moisture control and condition of rainfall and irrigation. I should get an image for this. Roots in soil organisms, both macro and microflora and fauna, occupy these pores. What proves crucial to both atmosphere and soil is that neither is to be grasped as a system of functionality of parts and wholes, but rather as assemblages due to bricolage. As we will see in the following section, part of the arboreal specificity of trees is precisely their functioning as bricoleurs. So this account of soil is really interesting, and it's too detailed for me to go into here. But basically, we just think of soil or earth as this tiny little particles in the ground. But in fact, they're not only these particles, but up to 50% is like spaces in between them. And those spaces are crucial for their existence. So it's not, the earth is not a homogeneous medium. It's actually a mixture. It's heterogeneous mixture of tiny rock particles, water, and air, in the same way that breath is also a mixture. And of course, trees are rooted in soil and then grow up and process and breathe through air. And so both of these elements are crucial. Third part, arboreal entanglement. Almost anything true of plants is true of trees, although the reverse is not always the case. Trees have a distributed structure like all plants. Trees share plants' immediate relationship with the world, taking their nutrients from reality in its most basic components: rocks, water, air, light. And like plants, trees share an intimacy with both breath and soil. Plant theorists, however, often move between discussing plants in general and discussing trees in particular without explicitly attending to the question of the specificity of trees. They often say things like plants, including trees. And I'm interested in what's specific to trees in this section. In seeking to articulate an arboreal specificity, I don't seek to reproduce the logic of exceptionalism. Arboreal specificity is not the same as arboreal exceptionalism. There's no ontological break between trees, plants, fungi, or any other organisms, or between atmosphere and soil, for that matter. Unlike primates, for example, all of which are genetically related, there's no phylogenetic connection among trees. To suggest that there are specific qualities of arboreality that distinguish trees from other forms of plants is not to deny that trees are plants, but to insist that they possess what we might call, following Charles Sanders Peirce, tendencies to form similar habits. Although different species of trees develop different habits, in this section I'll focus on 3 habits shared among virtually all trees: their formation of wood, their habit of becoming with others, to borrow a phrase from Donna Haraway, and their unusually long lifespan, including their afterlife. So I was surprised when I started researching trees to realize that trees do not, in the evolutionary tree, all come from the same branch. Primates are all descended from the same branch of primates, dogs, canines, and so forth. But trees come from all sorts of different plants. So trees are not a unified biological category. Trees are something we define, in a sense, by their tendencies to form habits. And these 3 habits I'll discuss, but there are others that most trees share as well. The tendency of trees to form wood, which provides the raw material for human dwellings and other social and technical artifacts, has been crucial to humans from their earliest days. Dendroclimatologist Valerie Trouet contends that it would be no exaggeration to say that human civilization as we know it is founded on trees. Roland Enos makes a similar point in his 2020 book, Age of Wood, which narrates human interaction with trees and wood starting as far back as pre-human primates. And the very recent study in the Proceedings of the National Academy of Sciences has made the case that the Pleistocene could just as easily have been known as the Wood Age as its more commonly accepted Stone Age moniker. And one of the reasons that stone is so prominent for archaeologists is that wood doesn't last as long. It lasts a long time, but when you go back millions of years or hundreds of thousands of years, what's left are things made of stone, but wood tools and all sorts of woods for habitat and structures were essential and more widespread for human culture than stone. Not only is wood made up a major portion of human infrastructure through the course of our history, but humans are entangled with trees in ways we don't always fully acknowledge. Enos draws on recent work in anthropology and cognitive science to show how some of the key evolutionary characteristics that distinguish humans from other species, the development of perspectival sight over smell, complex depth perception, and the grasping abilities of feet and hands, that these characteristics developed from arboreal primates. In this light, it might not be overstating the case to think of the human reliance on wood and trees as an example of the coevolution of humans and trees, understood along the lines of Gilbert Simondon's claims about the coevolution of humans and technology. Indeed, following Simondon, we might say that trees and wood are the first human technologies, and that the individuation of humans emerges from the pre-individual being of arboreal primates. The tendency of trees to form wood not only plays an important role in the coevolution of humans and trees, but it's crucial both to their comparatively long lifespans and to their entangled, as trees comparatively long lifespan, and their entangled coexistence with organic and inorganic entities. Interestingly, and in contrast to most plants, the wood from dead trees continues to interact with countless other species after the tree dies, often for many more years than it did while part of living trees. In a fascinating book called Dead Wood, The Afterlife of Trees, Ellen Wohl, a scholar of river form and process, traces the lives and afterlives of 3 different North American trees, river trees, an Engelmann spruce, a western red cedar and fir, and a balsam poplar. Wohl's biographies, as she calls them, show how these trees engage with each other, or how these trees engage with each of the 3 habits I've delineated. And here's just one slide to give you a sense of the life of a tree as it lives and dies. One of the ways Wohl describes what I understand as radical tree mediation or arboreal entanglement is by showing how certain endophytes and epiphytes, you didn't know you're getting a science lecture here, help keep Engelmann spruce trees alive by fixing the nitrogen they need to live. Although it's true that the Wood Wide Web's mycorrhizal networks provide the spruce and all trees with nitrogen in exchange for carbon, that nitrogen needs to be converted into usable compounds by the spruces becoming with both endophytic bacteria and epiphytic lichen. This is just 2 examples. In a mutualistic exchange, one species of endophytic bacteria that grows within the plant takes its nutrients from the spruce needles in which they live at the same time that they stimulate plant growth and help protect against disease by enhancing the plant's acquisition of nitrogen. Wohl contrasts this mutualistic process of endophytic remediation, which is especially valuable when the spruce is still young, with another nitrogen fixing operation that becomes more prominent as trees mature. She describes how epiphytes like lichen are, I don't know if you what the Italian word is, but these plants simple plants that grow on trees but do not grow within them or do not exchange nutrients. These epiphytes, like lichen, gather moisture and nutrients from the environment of the spruce, but not from the spruce itself. Both organisms, however, the lichen and the bacteria, help keep the spruce alive by fixing the nitrogen the trees acquire from the hyphal networks in the soil. So fixing it means it acquires this nitrogen, but it needs basically to be like digested. And these bacteria and these lichen help the trees convert the nitrogen into a form that it can use and help it grow. Once we stop thinking of trees as autonomous individual organisms, as systems of functionality of parts and wholes, the boundaries between where a tree begins and where it ends becomes increasingly difficult to fix with any certainty. Perhaps we might even say that the endophytic bacteria and epiphytic lichen that fix the nitrogen are themselves parts of the tree as arboreal assemblage, just like its leaves, bark, heartwood, or roots. So all the parts of the tree that we identify with the tree, my suggestion is that these other organisms are also part of the tree as an assemblage because the tree needs them in order to survive, the same way it needs its roots, its bark, its leaves. In considering the afterlife of dead wood as a crucial chapter in a tree's biography, Wohl also challenges the boundaries between when a tree's life begins and when it ends. Michael Marder has complicated the idea that a seed marks the originary point of a tree's life by explaining how seeds always function as middles, sites in which roots and shoots emerge together, linking the media of soil and atmosphere in the seed's two-way growth. Doesn't just grow up from a planter, doesn't just grow up from a seed, it grows in both directions in order to come into existence, linking atmosphere and soil. Similarly, Wohl's descriptions of what happens to trees after they turn into dead wood allows us to see how even after they die, trees continue becoming with others in ways very much like they do when they're still alive. This indistinction of dead wood and living tree already exists throughout the mature life of the tree, as the heartwood of its trunk and principal branches dies as the tree grows, turning into infrastructural elements of the living tree. Ulla describes how the dead wood that is reinforcing the sturdy structure of a tree expresses both a future-oriented disposition, reflecting support of current and future growth, and simultaneously entails in its dead wood a direct material memorization of its past through the formation of tree rings for each year of the tree's life. So again, you may not know this, but while a tree is living, a big part of it is already dead. The wood on the inside that we end up using when we cut trees down it dies and just becomes a kind of infrastructural, not just, but becomes an infrastructural support for the tree. So a tree is already alive and dead at the same time, but that becomes even more interesting when we see what happens to the wood of a tree after it dies. So Wohl's account of her life, of the afterlife for Engelmann spruce, follows its dead wood beyond the tree's nominal life of 450 years, when it was taken down by an infestation of spruce beetles. She describes 3 stages of its afterlife, each of which demonstrates how the dead spruce wood, like the living tree, becomes a new medium for the entangled coexistence of multi-species assemblage. And here are some of the stages of dead wood. A snag, what Wohl calls the next phase of the trees, and this is a snag up there. It's a part of a dead tree that's still standing. Like it did when it is alive, the spruce snag hosts a variety of organisms. Fungi create rot by breaking down the woody tissues of the tree. Cavity nesting birds build nests by enlarging small patches of decayed wood. Other birds feed on insects that themselves feed on decaying wood, and in some cases, as with carpenter ants, build nests in the snag for their colonies. With the addition of bacteria, fungi, and diverse invertebrates to its tissues, Wool writes, Wool writes, the snag contains substantial living biomass, albeit in a different form when the tree was alive. Nutrients carried in on rainfall and snowmelt also accumulate on the snag. So the snag is dead, but it has biomass, living mass, even after it's dead. So trees are, I mean, I'm a big tree fan, as you can tell. Trees are these phenomenal kinds of plants that while they are alive are both living and dead. And then after they die, they are in a sense, both living and dead, the same kind of organic processes that go on during their life go on afterwards. Not the same processes necessarily, but the same kinds of processes. Wool similarly describes how coarse woody debris, large pieces of downed wood like the fallen branches and trunks one finds on any forest floor, also participate in the creation of these multi-species assemblages. Focusing mainly on the spruce's fallen trunk, whose deterioration into an amorphous, homogeneous mass, that's like D near the end, can take as long as 800 years, far longer than most spruce live. She describes the trunks becoming with others. And this is a quote from her. Beetle and termite miners bore a mass of tiny tunnels through the interior of the wood. Bacteria and fungi grow along the tunnels. Columbilon and mite grazers follow their food sources into the tunnels. Fungi grow on the bodies of those who die in the tunnels. This entangled tunneling through the dead wood dissolves the wood, enabling plants to grow from the rotting trunk through association with the mycorrhizal fungi in the decaying tree tissue. So just as living trees and plants associate with these fungi underground, they also, new plants and new trees grow out of the decaying tree tissue where there are similarly these fungi. In essence, Wool concludes, insects, bacteria, and fungi start making the fallen tree sufficiently porous to allow flows of plants and animals, air, water, and nutrients between the downed tree and its surroundings. And the porousness of the deteriorating tree is like the porousness of soil we talked about before. The transformation into soil of coarse woody debris dramatizes how centuries after their death, trees continue to participate in the same processes of nutrition and waste, growth and decomposition that they participated in when they were alive. If such processes are essential to the tree's life, their continuation for centuries after the spruce has died makes it difficult to demarcate a firm boundary between life and death in the multi-species assemblage that we call a tree. Final section is tree mediation. When Suzanne Simard describes trees and forests communicating through a wood wide web, excuse me. When Suzanne Simard describes trees and forests communicating through a wood wide web, whose formal structure she describes as analogous to the internet, her aim is to suggest that trees use mycorrhizal networks to send messages, excuse me, just like we use the internet. When she extends the network metaphor to neurology by showing how trees share the same chemicals among their mycorrhizal networks that human brains send through our neural networks, the image of an emergent superorganism is meant to give pause to those who would clear-cut entire tracts of forest for timber. And by creating the metaphor of the mother tree, which furnishes nutrients to its arboreal offspring, even as it's dying, Simard hopes to make taking down such mature and nurturing trees seem like an act of domestic violence or matricide. Given that widespread distribution of her work across the internet has had a powerful impact on people's understanding of and attitudes toward trees and forests, she's clearly gone a long way towards shaping the idea that trees communicate, think, and cooperate among a broad swath of the public. But I've begun to wonder if the best way to make the case against deforestation, which is what she's interested in doing, is by arguing that trees and plants are like us. By using human intelligence, sociality, and technology as the measures of arboreal complexity, do we continue hubristically to perpetuate an invidious distinction between humans and non-humans that underwrites the exploitation of the natural world and is inimical to multi-species thriving and well-being, indeed to the planet as a whole? While I would reject outright the idea predominant in Western civilization for millennia that plants, trees, and forests, indeed the natural world itself, exist solely as resources for human use and dominion, I'm less sanguine about recent claims that trees and forests think and talk and love like humans do. As much as I'm attracted to that idea, it is kind of cool, I am not convinced that we need to impose the form of human, technically mediated networks onto plants, trees, or the material interconnections of roots and fungi in order for them to have value. By doing so, by imposing our structures on trees, risks reproducing the hylomorphism that plants and trees resist. What if, rather than starting with our neural or technical networks as the measure of arboreal intelligence, we turn this around and began instead with something like tree mediation as the measure of the human? What if we considered the internet itself as taking the form of mycorrhizal networks? Might it make sense to consider human cognition and communication networks as themselves arboreal? What would it mean to think of technical networks and mycorrhizal networks as the same kinds of thing, to consider the internet and even our neural networks as themselves part of the coevolution of humans and trees? Do trees communicate and share, cooperate and care like humans do? Or do humans do these things like trees do? Are trees like us, or are we like them? This is not just a matter of words. I mean, trees have pre-existed us for a long time, and they were crucial, as I suggested earlier, in our evolution as arboreal primates, in our evolution, in our use of trees and wood, crucial in our this coevolution of humans, in the emergence of humans and technology. So in raising these questions, I do not mean to rehearse epistemological arguments for or against anthropocentric perspectivalism. That is, the idea that humans are trapped in our own cultural linguistic prison house and thus can never attain a biocentric viewpoint or a truly non-human perspective. The choice between anthropocentrism and biocentrism is a false choice, an offshoot of fundamental dualisms that have dominated Western thought for more than 2 millennia, dualisms that have been challenged by plants and trees. Such dualisms have been largely underwritten by ideas of human exceptionalism, particularly the ideas that language use and ability to make ethical or moral judgments are what separate humans from non-humans. Instead of measuring trees against humans, what if we asked what arboreal cognition and communication might teach us about our own cognitive and communicative practices? Rather than granting trees a kind of intelligence according to our exceptionalism as self-conscious free agents with the power of language or speech, what if we understood these human capabilities as operating on the model of tree mediation or arboreal entanglement? Michael Marder addresses similar questions about what it means for plants to communicate, contending, quote, plants help us provide some of the initial responses to this inquiry by revealing that the message or what is communicated is not separate from the communicating agent, which is a communal being at every level of its cellular tissue and environmental architecture. Much in the same way, human language erroneously identified with communication in toto is not a tool for the transfer of information, but part and parcel of our ontology, our inherent communal makeup. Just as the form of the plant is not separate from its creator, what a plant communicates is not separate from the communicating agent. Rather than seeing human language as the expression of freely chosen messages sent by autonomous individuals, Marder suggests that we consider human language and cognition as part of our ontology, our inherent communal nature, not unlike how tree rings or mycorrhizal networks express the ontology and communalism of trees and fungi. Trees do not decide to add branches and growth rings or participate in entangled multi-species assemblages any more than humans choose to use language or to live socially. And that's humans generally, not to say that individual humans might not make these choices. Rather than simply reverse the human non-human dualism, though, I want to close by suggesting that, like trees, humans have been co-evolving with multi-species of arboreal assemblages for millennia, really. Following Simondon and others who maintain that humans have co-evolved with technology, I would extend this mutual relation to the co-evolution of pre-human primates with the arboreal. Like trees, our technological infrastructures are not other from nature, but of a piece with it, growing along with humans like the wooden trunk of a tree grows infrastructurally to hold up the living tree. What would it mean to consider the coevolution of humans and technology as an offshoot of the coevolution of humans and trees? Over the course of this century, some data-minded technologists have tried to engineer new ways of technically co-evolving with trees and forests. Through the datafication of forests, they've begun to address problems of deforestation in eco-technical projects that would transform the idea of the Wood Wide Web into what they call an internet of trees. By linking trees to technoscientific networks via QR codes, satellite data, and machine learning, these projects would transform trees into technologies of mediation to aid in the fight against climate change. GPS-guided drones have now begun to be deployed to plant trees by dropping seed balls more quickly than humans can plant them, and in hard-to-reach locations that humans cannot easily get to. While all of this is an intriguing project, or are intriguing projects, I have my questions about these networked arboreal technologies. Not unlike the metaphor of the Wood Wide Web, which imposes human models of technical networks onto the arboreal networks of tree mediation, the materialization of trees as what scholar Jennifer Gavris called technologies of planetary governance would seem to bypass or ignore the recognition that trees and forests are already technologies for managing the environment, that forests are already smart without needing to be equipped with sensors or QR codes or mapped digitally by drones or other network sensing technologies. Whether as metaphor or as technical materialization, the Wood Wide Web or the Internet of Trees risks subordinating arboreal entanglement in order to instrumentalize trees and forests for the economic, political, and social well-being of humanity. Now, my concluding paragraph, What I would suggest instead is that if we're going to engage in wide-scale re-engineering of our forests, we need to adopt an arboreal perspective on these technologies in order to consider what we might learn from trees. We've seen how living trees and dead wood associate in multi-species assemblages that continue to thrive well beyond a tree's life. The same is true in some sense of the planned obsolescence of our electronic technologies in their creation, their usable lives, and their afterlives as waste. Unlike trees, however, which continue to generate and support new lives, even after they're dead, our network media technologies consume more organic and inorganic energy than they produce. And after they're dead, they do not contribute to the mutual thriving of humans and non-humans. We might learn from trees something instead like an arboreal temporality, to take a longer term view than neoliberal capitalist effort to maximize profit and economic productivity in the shortest possible time frame. Such an arboreal temporality might encourage us to make our digital technologies accountable for their interrelations with organic and inorganic entities in such areas as the mining of rare minerals, their obscene consumption of energy, and the afterlife of their materials after they die. In learning from trees, we might also take a cue from their relative immobility, which has led trees to evolve collaborative strategies for surviving their fixedness in place, their rootedness in their environment, rather than as humans have done for millennia, moving on to the next frontier when faced with ecological or economic disaster. Perhaps we should follow our arboreal ancestors and accept our responsibility for the planet on which we live. In other words, by thinking of ourselves as being like trees rather than trees being like us, by accepting our arboreal entanglement with multi-species assemblages and with technology, we might begin to consider new ways of relating with the non-human world, not as separate from, but entangled with us. Technocultural dreams of colonizing space notwithstanding, humans are for now as rooted to the earth as the trees among which we live. For the foreseeable future, for better or for worse, human life on this planet will remain, I suspect, arboreally entangled. Thanks.